All right, now time for the last part of this semester review, answer key. All right, so the derivative of e to the negative x, well, e to the x is its own derivative, so I should just end up with e to the negative x, but then I just have to take it times the derivative at the top, so my answer should just be negative e to the x. Okay, number 25, okay, I know that's really hard to read, but it is e to the x squared plus 4x. Well, again, this is its own derivative. I just then have to multiply it by the derivative of the exponent. So it looks like that. So that would be my answer on that one. Go down to 26. Okay, so we're going to integrals, so we have to go backwards. So that means I need to make sure that the exponent's derivative is somewhere in the problem. Well, in this case, the exponent is negative 2x. Well, I don't have a negative 2 for the derivative, so I'll just put 1 out in front. And then my answer just becomes that, negative 1/2 e to the negative 2x. Okay, like it's its own derivative, so the integral of it would just be the exact same thing without the derivative of the exponent. So there we go. Number 27. Let's see, the exponent is tangent of 2x. Well, the derivative of that is secant squared of 2x times 2. So I don't have a 2 anywhere, so I'll just put a 1/2 out in front. So then I have 1/2 the integral of e to the u du. So my answer should just be 1/2 e to the tangent of 2x plus c. Oh, I forgot the plus c on number 26. Okay, number 28. We need to find the general solution. So I need to get x and y on, or excuse me, I need to get y over on the same side as dy over dx. So I'll multiply it over, so I have y times dy over dx equals 5x. Now I'll integrate both sides to get rid of the dy over dx. And because this here is its own derivative, that means I'm now integrating for y, so that means I should have y squared over 2 equals, well, this I will integrate for dx, or for x, so now I should have 5 over x squared, or 5x squared over 2 plus c. Well, I can think that that's just a c1, and then multiplying everything by 2 to get rid of the fraction, I can just say y squared is equal to 5x squared plus c. Alright, so basically saying that c1 times 2. Okay, now number 29, Newton's law of cooling. So let's see if we can remember this. I believe it should be y is equal to the air temperature, which is 60 degrees, plus c e to the kt power. Alright, so if it was initially at 1,100 degrees, if I let t be 0, let's change that from a y. Let's say that is 1,100, okay, equals 60 plus some number e to the k times 0. Well, that means this is all 0, or this is all 1. So if I subtract 60 from that, c is equal to 1,040. Right, so let's erase all this again, and let's rewrite our equation. So then we should have y is equal to 60 plus 1040 e to the kt power. Okay, next bit of information says 1 hour after it is removed, the core temperature is now 900. So our end result is now 900 equals 60 plus 1040 e to the 1k. Very nice. Okay, so we'll do some math here. We'll subtract off the 60, and then we'll divide by the 1040. So we should end up with, looks like 0.8077 is equal to e to the k power. Okay, now to get the exponent off the top, we'll take the natural log of both sides, and then the power goes in front. So we have the natural log of this here equals that natural log of that. So we'd have the natural log of e to the k. K goes in front, so then it should just be k times the natural log of e. Well, that's 1, so that means this here is what k equals. Okay, so natural log of that number comes out to be k equals negative 0.2136. All right, now, so for my equation up here, I will now write in the new number, negative 0.2136. And it says, okay, now find out the core temperature after 5 hours. So then I'll plug that in up there as a 5, and now we'll just run through the calculation. So we'll take k times 5, and then we'll raise that to the e power. So I get, for all this up here, for all this e, all that to the same power, I get 0.3437. Now I'll take that number times 1040, and then I'll add 60 to that. So what I get for an end result is I get 417.49 degrees Fahrenheit. Okay, so that's what I get for that one. Okay, now for the last problem here, we need to figure out, let's see, find the exponential growth model for this question and then project its population in 10 years. So if the population now is 2 million or 2.9 million and it's projected to reach 10.9 years, so that means we need to find k. So let's say that let's say y is equal to, okay, it's now 2.9, e to the k, well, and then 10 here. Oh, probably should have put this in as 3.4. Like that. Ooh, that's a really bad 10 over there. Let's write that in. There's a 10. Okay, first thing I'd do is I'd divide by 2.9 over. So 3.4 divided by 2.9 gives me 1.17 is equal to e to the 10k power. Natural log both sides. So I have the natural log of 1.17 is equal to 10k natural log of e. Using that power rule to slide that in front. That goes away. Divide by 10, divide by 10. So my answer is going to come out to be the natural log of 1.17, all divided by 10. So we will take the natural log of that and then divide by 10. Answer is 0.159. So my equation that I will want to have, let's do that in blue, y is equal to 2.9 e to the 0.0159 t power. Okay, because it just wanted the model.